Okay, so we've got a curve here, it's got this equation, alright, which I've written down here, and they're asking us then to find the equation of the tangent and normal. So when we've got the curve like this, what we need to do is differentiate, okay, when it comes to looking for the tangent. So differentiate dy dx, and we can't differentiate when we've got x term on the bottom here, so we need to take that up. So I'm going to rewrite this to start with, so keep the first term as it is, but take that x up. So if I take it up, it'll become x to the minus 1, yeah, because it's x to the power 1 here. Take it up, x to the minus 1. So I'm going to differentiate dy by dx. Essentially what you do is then, remember, you bring the power down. So 3 over 2 is that power. Bring it down, times it by the 3. You should calculate it if you want, just to check. 3 over 2 times 3 is 9 over 2. X then, well, take away 1 then. Remember, you always take away 1 from the power. So 3 over 2 take away 1 is a half. Again, use your calculator to check. This power here, minus 1, bring it down. So minus 1 brought down, times by minus 32. Well, it'll become a plus, won't it? Because minus times a minus is a plus. And then take 1 away from that power. So you get minus 2. Okay, what will help, okay, particularly with these type of questions, is to then rewrite this. Okay, so what I mean by rewriting dy dx, for instance here, x to the power half, you should recognize as the square root of x. Okay. And then you've got here 32 on the top, x to the minus 2, take it down, and become x squared on the bottom, yeah, because it's a negative power, take it back down. Now they want, in part A, the equation, okay, of the tangent to C at the point where x is 4. Now just remember, you know, suppose this is my curve, and that was my point x equals 4. The tangent, quite simply, would be a line, yeah, which just touches at that point x equals 4, okay, right, so that would be my x value there. We want the tangent. Now remember, the tangent is simply measuring we can get the gradient from there, yeah, okay, quite simply from that, and it'll be the same as the gradient of the curve, yeah, because the tangent's got the same slope as the curve there. So what we can do is, we can say, look, when x is equal to 4, dy by dx will equal to, just sub it in here, yeah? Sub it in here, so we'll have square root of 4 there, plus then 32 over 4 squared, okay? So, you know, you can work all that out in one go on your calculator, alright? And you get 11, okay? So that will be the gradient of the tangent. So we must remember that. We've got dy dx, okay, which is the gradient of the curve, okay, at the point here, x equals 4, yeah? Okay, but remember, it's the same as the gradient of the tangent, isn't it? Because the tangent it's got the same slope as the curve, yeah? At that point where it touches, it's going in the same direction. That's what a tangent is. So we've got the gradient of the tangent. And for an equation, you need a gradient, okay? We also need a point on that curve, and of course the perfect point is this one here. We know the x value, we don't know the y value, don't we? It's just we just don't know what it is. So we go back to this y curve here to work out what x is going to be. So we'll also say that when x is 4, y will equal to 3 times 4, the power 3 over 2. Okay, and put 4 in there as well. So we can work that out on our calculator. And we get out 16, okay? So the equation of the tangent remember, we follow that equation here. So we put in y, which is 16, a gradient, which was 11, and then an x value, which is 4. So we'll just simplify this nicely then. Okay, so it doesn't matter really what format which way you put it in, just simplify the numbers here. So we could say, look, 11x minus y, okay, minus 28 equals 0. It really doesn't matter. You could have y equals, if you wanted to, 11x minus 28, okay? I just take that minus 16 over it, it really doesn't matter. Part B then, they want the equation of the tangent. Now remember, with the tangent, sorry, the equation of the normal. There was a normal, okay, at a particular point. The normal is perpendicular to the tangent. So if we've got our tangent here, I'll draw it like a broken line. The normal will be perpendicular to it. Okay, so it actually goes through the curve. Okay, like that, yeah. And if this was a circle, okay, it's not a circle, but if it was a circle, that normal then would go through the center of the circle, yeah, because it's perpendicular to the tangent. That would be your radius, wouldn't it? But it's not a circle, it's just a curve. You just got to appreciate the normal here is perpendicular to that tangent. So if it's perpendicular to the tangent, we just use the rule, don't we? M1, M2 equals -1. Okay, so 11 is what the gradient of the tangent is. So to get M2 then you just take that 11 over divide. So that's the gradient of the normal. Okay, so of course we know the point is 416, we've already worked that out. So we'll do the equation then, y minus y1 to be y minus 16 equals to then minus 1/11 x minus 4. Okay, so you take that 11 up. Don't forget then you've got a -1 here. So you get 11y minus then 176. Multiply through by the minus, you get minus x plus 4, and then you can leave it then in a nice format to finish off. Okay. So get everything maybe to one side, and you've got your final answer there for the equation of the normal.